Good afternoon, dear students.
Good afternoon.
Yes. Okay. So today, so in the last class, we have discussed about the solution chapter. Some many questions. Did you solve any more questions?
Looks like we can't hear you well.
Yeah. Okay. So today we are going to start with the next chapter, that is haloalkanes and haloarenes. I'm audible, right?
Yes, ma'am.
So let us start. So haloalkanes and haloarenes, right? So what do you mean by haloalkanes and haloarenes? So all the, I hope you have studied the synopsis. Yes.
Yes,
So
ma'am.
alkanes are what? They are the alkyl halides, right? They are the alkyl halides. So you have a alkyl group and halogen. So one of the hydrogen atom, okay, when it is replaced. So one of the hydrogen means, so here CH3. So one of the hydrogen atom is replaced by a halogen group. So the halogen can be your chlorine, iodine, bromine, fluorine. Okay. So these result into what? These result into alkyl halides. And what do you mean by aryl halides? So aryl halide means what? A aromatic ring is present. Okay. So aromatic ring. So of that aromatic ring, one of the hydrogen will be replaced by a halogen. So these are haloarenes. So these are called as haloarenes, and these are called as haloalkanes. Okay, fine. So why arenes? Because you have a double bond, right? In the benzene ring, you have a conjugated system. So it is called as what? They are called as the haloarenes, right? And here they are saturated compounds. So they are called as haloalkanes. Fine. So let us start with the question. So this is the first question. How many optically active stereoisomers are possible for butane 2,3-diol? How many optically active stereoisomers are possible for butane 2,3-diol? Okay, so how you are going to solve this? So firstly, what you need to do, you need to know the structure of butane 2,3-diol. Okay, so butane means what? A compound with 4 carbon atoms, right? So CH3, right? Then C and CH3. Okay, so we have 4 carbon atoms. Now at the second position and third position, we have diol. Diol means what? All means alcohol group, right? So we have 2 alcohol group. Okay, so here, so this is the compound. So this is what? This is butane 2,3-diol. Okay, so this is what? Butane 2,3-diol. So at 2 position and 3 position, you have OH group. Now they have asked how many optical active stereoisomers are there. Okay, so you have to calculate here what? You have to calculate the number of asymmetric centers, okay, or the chiral carbon. Okay, so you have to calculate what? Number of asymmetric center or the chiral carbon. So here, how many asymmetric, what do you mean by asymmetric or the chiral carbon? So the carbon will have 4 different groups attached to it, right? Now here, 1, 2, 3, and 1, 4. So this is one chiral carbon, right? Then another chiral carbon. So if I see this particular carbon, so this is one group, this is another group, so another group, and this is another group. So this is chiral carbon. If I see this carbon, okay, this CH3 carbon. Now CH3 carbon, so to that CH3, okay, so we have 3 same hydrogen atom. So this is not a chiral carbon. So similarly, this also. Understood? So what is chiral carbon? So to that, a carbon which is having 4 different atoms or groups. Okay, it is called as what? It is called as chiral. So here, how many chiral carbons are there? So here, 2 chiral carbons are there. So when I want to calculate the number of optical isomers, so the formula is 2 raised to n. Okay, the formula is 2 raised to n. So it is 2 raised to, how many chiral carbons are there? 2. Okay, so it will be what? It will be 4. Okay, now here, when I'm seeing here, okay, so it is 4. Now, now here the number of optically active stereoisomers. Okay, now we calculate the optically active stereoisomers. So you have to minus 1, okay, because you will be having one meso compound. What do you mean by meso compound? Okay, so when you put the stereo center, okay, when you have a mirror, okay, so one half of the compound will be cancelled by the other half, right? So because of that, so one of the compound is optically inactive. They have asked what? How many optically active isomers are there? Okay, they have not asked optically inactive. So one of the compound is a meso compound. Okay, so this is a meso compound, right? So if I put one mirror, so half of the compound, okay, half of the molecule will coincide with the other half, right? And it will get cancelled off. So this resulted compound is called as the meso compound. So what I have to do? I have to minus the 1. Okay, I have to minus 1. So it is 3. So how many optically active isomers are there? It is 3. Okay, so one of the compound will be a meso compound. So I have deducted that meso compound. So it will be 4 minus 1, that is 3. Okay, so which is our answer? Our answer is option number A. Okay, option number A is the answer. So 3. So 3 optically active isomers are present, possible for this compound, that is butane 2,3-diol. Okay, fine. Let us go. So this is the answer, option number A. Okay, let us go for the next one. N-propyl bromide on treating with alcoholic KOH produces. Okay, now let us write the structure of N-propyl. Propyl means 3 carbon atoms, right? So it is CH3, CH2, CH2 and bromide. So it is Br. N-propyl means it is a straight chain. Okay, we are writing the compound in a straight chain. So here N-propyl bromide, we are treating it with what? We are treating it with alcoholic KOH. Alcoholic KOH means what? We have prepared potassium hydroxide in alcohol. Okay, alcoholic solution. We are not using water. Okay, we have used ethanol, or that is your alcohol. In that alcohol, we have dissolved this KOH. Okay, so it is called as alcoholic KOH. We do aqueous KOH means what? Aqueous means we are using water. To dissolve the KOH, we are using water. So that is called as aqueous KOH. Alcoholic means what? KOH is dissolved in alcohol. Okay, so we have taken what? Alcoholic KOH. So what is alcoholic KOH? It is called as what? Do you know? What is alcoholic KOH called as? What is this reagent called as? It is called as a dehydrohalogenating agent. Okay, remember this, very important 1 mark question. Okay, what is alcoholic KOH? Alcoholic KOH is a dehydrohalogenating agent. Okay, dehydrohalogenating agent, right? So what is alcoholic KOH? Alcoholic KOH is dehydrohalogenating agent. Fine. Now here, so dehydrohalogenating means what? Dehydrohalogenating means D means removal of. Okay, so we are removing one hydrogen. Okay, we are removing one hydrogen and one halogen. Okay, HX. So there is a removal of HX group. Okay, so alcoholic KOH is such a reagent which helps us to remove one hydrogen and halide group. Okay, so now from this N-propyl, your N-propyl bromide. Okay, let us see N-propyl bromide. So N-propyl bromide, we are going to remove what? We are going to remove the your hydrogen halide. So let me show you how we are going to remove. So CH3, CH. Okay, so I'll describe you properly. So H, H and Br. Okay, so what will happen? So one hydrogen and one halogen will be removed. Okay, like this. And what will be the resulted compound? The resulted compound will be a propene. Okay, so it will be a propene. Understood? So this will be a resulted compound. Sorry. Here CH3, then CH. Okay, then there is a formation of double bond here, and then CH2. Okay, so one hydrogen and one halogen is removed. So what is the product form? It is a propene. Okay, it is a propene. So plus KBr and water is the byproducts obtained. So which is the answer? Our answer is option number D. Okay, remember this. What is alcoholic KOH? Alcoholic KOH is a dehydrohalogenating agent. Okay, very important. dehydrohalogenating agent. Okay. Dehydrohalogenating means removal of hydrogen and one halide, HX. Okay. X can be your any halogen, chlorine, bromide. Okay. So this is a dehydrohalogenating agent. Understood?
Yes, ma'am.
Okay. Let us go for the next one. An organic compound on heating with cuprous oxide produces CO2 but no water. So what is the organic compound? So what is that organic compound? Okay. Now here what they have asked, so there is one organic compound. So if you heat that organic compound with cuprous oxide, okay. So what you are going to get? You are getting CO2 but no water is obtained. Water is not obtained. Okay, but carbon dioxide is obtained. So what is the organic product they have asked? Okay, now since the compound it is not producing water but it is producing carbon dioxide, okay, so that means what? The compound is not having hydrogen. Okay, the organic compound is not having hydrogen. So here if I write the formula, so chloroform is CHCl3, methane is CH4, ethyl iodide is CH3, CH2I, and carbon tetrachloride is CCl4. Now in this, if I write from this options, in which of the following you can see that there is no hydrogen present?
Option D.
Option D, right? So since the compound it is producing carbon dioxide and not water, means what? The given compound does not, organic compound does not contain hydrogen. So you need to know the molecular formula of all the whatever the options are given of the organic compounds. Okay, so by that you can analyze which compound is not having hydrogen. So carbon tetrachloride, if it reacts with cuprous oxide, it produces what? Carbon dioxide and not water. So option number D is the correct answer. Okay, let us go for the next one. A dibromo derivative of alkane reacts with sodium metal to form an alicyclic hydrocarbon. So what is the derivative? Okay, so a dibromo derivative of alkene is there and that is reacting with sodium metal. Okay, it is reacting with sodium metal. Now what is that dibromo? And it is forming a alicyclic hydrocarbon. Okay, and it is forming what? Alicyclic hydrocarbon. So the derivative is, so what is that derivative they have asked? So four options are given. So if it is reacting with sodium metal and it is forming a alicyclic hydrocarbon. Okay. So it is forming alicyclic. Okay, a cyclic form compound it is forming. So they have asked you to find which is that alkane. Okay, which is that alkane. So if I have a compound, so to form like this, okay, the your bromo groups, okay, dibromo groups, it should be at the corners. Okay, it should be at the corners so that it will eliminate and it will form a cyclic compound. Okay, now in which of the following you can see that they are at the terminal position, your bromo group. Okay, it should be a 4 carbon. It should be a 4 carbon atom and it should be what? It should be a butane. So our answer will be somewhere in B and D. Okay, now if I see B in B position, you have at second position only you have dibromo. So when you have at second position, it is very difficult to form a cyclic compound. But if you choose the fourth option, okay, that is at the first position, 2, 3 and 4. Okay, so here if you have like this, so then it is possible to form a cyclic compound. So our answer is option number 4. So it is what? 1, 4. Okay, then 1, 4. Then bromo butane. Okay, so it is our answer. So this is the compound. So if it reacts with sodium, okay, it is giving you what? It is giving you a alicyclic compound, that is butane. Okay. Reaction of methyl bromide with aqueous sodium hydroxide involves. Reaction of methyl bromide with aqueous sodium hydroxide involves A. Racemization, B. SN1 mechanism, C. Inversion of configuration, and D. SN2 mechanism. Reaction of methyl bromide with aqueous sodium hydroxide involves. Okay, so methyl bromide is what? CH3Br. Okay, reacting with aqueous sodium hydroxide.
Yes.
So what it is involves? Racemization, SN1, SN2, inversion of configuration, or SN2. Which is this mechanism? What type of alkyl halide is this? Can you tell me? Primary, secondary?
Primary.
Primary. So do you know in primary what type of mechanism it will undergo?
SN2.
SN2, right? SN2 mechanism. SN1 mechanism stability, if you know, tertiary compounds are more stable, then secondary, and then your primary. Okay, in case of SN1. In SN2, you have primary is greater than secondary, and then is your tertiary. So your primary, okay, so in SN2, primary carbocations are more stable. So in SN2 mechanism, what involves? There is a there is a what you say, transition state taking place. Okay, there is a transition state taking place. That is what will happen. Just a second, huh? H, H, H. Okay, so this is methyl CH3 and Br group. Okay, now here what is happening? Okay, as you can see, aqueous OH. Okay, so what will happen? The attack is taking place from backside. Okay, so when the attack is taking place from backside, what is happening? So there your okay, so it is getting an inverted state, and making and breaking of bond takes simultaneously. Okay, so your OH group is attaching to the carbon, and your CBr bond is getting broken. So this is called as a transition state, right? It is called as a transition state. So it in SN1 mechanism, it is SN2 mechanism, it is a one-step mechanism. Okay, it is a one-step mechanism. It involves attack of the nucleophile from the backside, and it undergoes a transition state, and the product formed will be what? What type of product is formed? It is a inverted product, right? It is a inverted product. So in the here, sorry, not, it is a just a second, I'll write here. Okay, so inverted product COH, H, H, and H, right? So here you can see your CBr, like this the compound was. Here it is getting inverted. The product is flipped, right? Because the attack of the nucleophile is taking from behind, right? SN2 mechanism. In SN2 mechanism, what will happen? The attack of the nucleophile takes place from behind. So in SN1, primary is more stable than secondary and tertiary. So they have asked, in this particular reaction, what all things you have observed? Did you see racemization? Racemization means what? 50% retention configuration and 50% inversion of configuration. Means both the products are half-half. But here the product formed. Okay, starting it is retention. Okay, you can see, and at the end, what is the product? It is completely inverted product, right? It is a completely inverted product. So option number A is wrong. SN1 mechanism, no. SN1 mechanism, it involves tertiary compounds. Okay, so there will be tertiary, but here we have a primary, so second option is also wrong. Then C option, inversion of configuration. C option is inversion of configuration. What do you mean by inversion of configuration? The compound form is inverted product. Okay, the compound form is a inverted product. So here you can see there is a inverted product. Yes, option number C is correct. Then it undergoes SN2 mechanism. Yes, option number D is also correct. So both these options are correct. It is forming an inversion of configuration also, and it is undergoing a SN2 mechanism also. So you need to know. Okay, so in SN1, what are the steps? In SN2, what are the steps? Is it clear?
Yes, Miss Ma'am.
Okay, and SN1 and SN2 mechanism, both the mechanisms are very important. Okay, please study those mechanisms for your boards. Okay, for board exams. So these two mechanisms, it should be very much clear. So don't forget to write the carbocation formation. Okay, carbocations, if you don't write, if you write everything and if you forget the carbocations, then they will not give you any marks. Okay, so practice the SN1 and SN2 mechanism thoroughly. Okay. So next question. Okay, so a similar question, you can write the structure. Okay, you have to calculate the optical isomers. Now here they have not asked your this one bromo 2 methyl cyclobutane. Okay, so the maximum number of possible optical isomers in 1 bromo 2 methyl cyclobutane is. Okay, so your answer should be your 4. So I'll give you the structure. Okay, you have to get the option answer as 4. So CH3. So at one position you have bromo, and at sorry 1, 2 and 2, 3 and 4. So and 2 position you have a methyl group and cyclobutane. Okay, so this is the compound. Okay, so maximum number of possible optical isomers in this compound, it should be 4. Okay, it should be 4. The answer should be 4C. Okay, fine. Let us go for the next one. Which of the following is not true for the hydrolysis of tertiary butyl bromide with aqueous NaOH? So tertiary butyl bromide with aqueous and tertiary. Okay, so tertiary. So let me write the structure. Tertiary butyl means what? How many carbons are there? 4 carbons are there. So it is a tertiary carbon. When we say tertiary, when we have 3 carbon atom or 3 carbon groups attached to the carbon, right? So this is a tertiary carbon. So the what is this? This is a tertiary carbon. So now to this tertiary carbon, okay, CH3, CH3. So this is a tertiary butyl group and a bromide group. So this I am going to react with what? I am going to react with aqueous NaOH. I am going to react with what? Aqueous NaOH. Okay. Now if I react it with aqueous NaOH, so what type of mechanism it will undergo?
SN1.
Yes, very good. It will undergo SN1 mechanism. Okay, SN1 mechanism is a two-step mechanism. So one step involves the formation of carbocation, right? And the second step involves the attack of nucleophile. Okay, attack of nucleophile. So first step. So let us form the carbocation. So what will happen? This bond is broken. So heterolytically, this bond, CBr bond is broken, and what is formed? A tertiary carbocation is formed. So this is the first step. So I said this. Okay, so like this, the carbocation should be written properly. Now, second step is what? Again, take the carbocation formed in the first step. Okay, and to this, what is happening? The nucleophile attack will takes place. The nucleophile attack will takes place, and this is the product form. Okay, so what is the product form? The product form is the tertiary butyl alcohol. Okay, the product form is the tertiary butyl alcohol. Understood?
Yes, ma'am.
Okay, just a second. Okay, so this is the SN1 mechanism, right? Now here, so these are the, now they have asked which is not true for the hydrolysis of tertiary butyl bromide with aqueous NaOH. First one, reaction occurs through SN1 mechanism. Yes, the reaction is occurring through SN1 mechanism. This is true. They have asked not true. Okay. Second one, the intermediate formed is a carbocation. Yes, the intermediate formed is also carbocation. So this is also a true statement. Now, rate of the reaction doubles when the concentration of alkali is double. So when we discuss the kinetic rate, okay, rate of the reaction, so the rate of the reaction depends only on the concentration of, do you know? the rate of the reaction depends only on the concentration of the substrate. Okay, it depends only on the concentration of the substrate and not on the nucleophile. So remember that. So because of that, it is a SN1 mechanism. Okay, rate of the reaction is, so when the rate of the reaction doubles, when the concentration of alkali is doubled. Now here, when you put the so if you take alkali more, okay, then what will happen to the concentration of the this also will be doubled. Now when the rate of the reaction doubles, when the concentration of tertiary butyl bromide is doubled. Okay, now here when we see here the option, okay, so hydrolysis of tertiary butyl bromide, okay, so it depends on what? It depends only the concentration of haloalkanes. Okay, so option number C. So option number C is the correct answer. So when the concentration of alkali is doubled, the rate of the reaction will be doubled. So it depends on the concentration of alkali only. So option number C is the correct answer. So you need to know the proper steps, okay, for SN1 and SN2. And in SN1 mechanism, tertiary carbocations are more stable, then secondary, and then is your primary. Okay, so this also you need to know. Okay. So following is the substitution reaction in which Cn minus is Cn, that is your cyano group is replaced, it replaces Cl minus. Okay. So RCN plus HCN. So RCl plus KCN, okay, in the alcoholic form, okay, gives you RCN plus KCl. So to obtain propanonitrile, RCl should be. So I want to form CH3, CH2, CN. Okay. So to obtain this, what should be my RCN, RCl? A chloroethane, B 1-chloropropane, C chloromethane, and D 2-chloropropane. So this is the general reaction. Okay. By using this, okay, so what I have done, I want to obtain this compound. Okay, I want to obtain this compound, that is a propanonitride. So what should be my RCl? Which should be my starting product?
Option C, ma'am.
Option C.
C.
Chloromethane. Chloromethane is CH3Cl. Chloromethane. Yes. Chloromethane, if I react with KCN, I am going to get what? I am going to get
C.
CH3CN. There should be 2 carbon atoms. Like this should be the compound.
Option A, ma'am.
Option A. Okay.
Option C, ma'am.
Yes. Ethane. So CH3, CH2 and Cl. So Cl will be replaced by Cn. Yes, option number A is the correct answer. So alcoholic KCN is taken, so that when you react with your alkyl chloride, you are going to get cyano group. Okay, cyanides are formed. Yes, correct answer. Very good. So remember this. Okay. Next question. Which of the following is not true for SN1 reaction? Again, which is not true? Read out. A. Favored by polar solvents. B. Tertiary alkyl halides generally react through SN1 reaction. C. The rate of the reaction does not depend upon the molar concentration of the nucleophile. D. Primary alkyl halides generally react through SN1 reaction.
Option D, ma'am.
Option D. Very good. So option number D. It is not true because primary alkyl halide, they react through SN2. Okay, and not SN1. So other 3 options are correct regarding SN1, but this is not true. Okay, let us go for the next one. The number of optical isomers for the compound. Yes, again you can write this compound CH3, CHBr, CHBr, and COOH. What is the number of optical isomers? So you have to calculate first the chiral carbon. So here the chiral carbons are 2 chiral carbons, so 2 raised to 2. So they have asked optical isomers. If they ask optically active isomers, Then you have to subtract -1. Okay, now how much it will be? It will be 4.
4.
Okay, so it will be 4. So option number D is the answer. Okay. Meso compounds do not show optically activity because meso compounds do not show optically activity because A, they do not have chiral carbon atoms, B, they have non-superimposable mirror images, C, they contain plane of symmetry, D, they do not contain plane of symmetry. Yes, meso compounds.
Option A, ma'am.
Okay, now this is an example of meso compound. So meso compound means what? Okay, so if I put up mirror, so one half of the compound will be same as the other half and it will get cancelled off. Okay, so optically active, so this is, you will have a plane of symmetry is present. Okay, which is this type of mirror what we are putting, it is a plane of symmetry. Okay, so meso compounds, what they contain? They contain plane of symmetry. So meso compound do not show optical activity because they do not contain chiral carbon atoms. They have they have chiral carbon atoms, right? Here you can see they have chiral carbon atoms. So this is uh, uh, what, this is not a correct option. It contains, okay, they asked do not show optical activity. Why they do not show? But meso contain they contain this. Then they have non-superimposable, yes, they have non-superimposable mirror images. They contain plane of symmetry. So they do not show optically activity. Why? It is due to containing the plane of symmetry. Okay, because of this plane of symmetry, they do not show optical activity. So option number C is the answer. So meso compounds, they contain this plane of symmetry, and because of this plane of symmetry, they are optically inactive. Okay, they are optically inactive. Okay, so option number C is the answer, correct answer. Okay, why they do not show the optical activity. Okay, an alkyl bromide reacts with sodium in ether to form 2,5-diethyl octane. The compound X is. So an alkyl bromide is there. Okay, let me write alkyl bromide like this. It is reacting with sodium. Okay, in the presence of dry ether. In the presence of dry ether. And it is forming 4,5-diethyl octane. Okay, 4,5 octane means 8, right? 1, 2, 3, 4, 5, 6, 7, and 8. Now at 1, 2, 3, 4, 4 position you have ethyl group, and at 5 position again you have a ethyl group. Okay. Now write CH3, CH2, CH2, CH, CH, CH2, CH2, and CH3. So this is what? 4,5-diethyl octane. Okay. Now here an alkyl bromide, it is reacting with sodium, okay, to form 4,5-diethyl octane. So what is this compound X? So they have asked what is this compound X? So what should be the compound X? And what type of reaction is this? Can anybody tell me when it reacts with sodium in the presence of dry ether? Name, very famous name reaction. Can you guess now?
Yes, reaction.
Woods reaction. Did you study about Woods reaction?
Yes, ma'am.
Yes, Woods reaction. So in Woods reaction, what happens? Two alkyl. Okay, so two alkyl. So two Na plus X plus. Okay. So if I give you the general reaction. Okay. Now I should have two alkyl halides. So there are two alkyl halides. Okay. It reacts with the sodium in the presence of dry ether. So what should be my product? My product should be RR plus 2NaX. Okay, so this is Woods reaction. So two alkyl halides should be present. Now to form this compound, okay, should break this bond. So what should be here? What should be present? So it should be your CH2, okay, CH2, CH2 and Br. So here one CH2, CH2 Br and here one CH2, sorry, CH3, CH2, 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 C2H5. So here one Br will come and here one Br will come. Okay, so like this you have to break the compound. So my two alkyl, this will be, so it will be CH3, CH2, CH2, CHBr and C2H5 plus, I'll erase this, plus 2Na plus CHBr, C2H5, CH2, CH2, CH3. Okay. So what is removed? So this is what? 2NaBr. So what now join this compound? So it will be CH3, CH2, CH2, CH, C2H5. Now this carbon, okay, where this is broken, so that will join. So it will be CH, C2H5, CH2, CH2, CH3. So what is the compound? The compound is this. Okay, so see, tell the name of this compound. CH3, CH2, CH2 twice, CHBr, C2C. So option number D, right? Option number D. So C2H5 is nothing but again CH2, CH3. Okay, so this is CH2, CH3. Understood?
Yes, ma'am.
Okay. So very important. Okay, so like this they will ask you. Okay, name reaction. So indirect way of asking the question. Okay, so option number D is the answer. Next one. Okay, cycloalkane formed when 1,4-dibromopentane is heated with sodium is. So cycloalkane. So again a cycloalkane is formed. Okay, how it is formed? When 1,4-dibromopentane. Okay, now let us write the pentane. So 1, 2, 3, 4 and 5. So at one position you have bromo, 2, 3, 4 and 4 position you have bromo. So CH2, 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 CH and CH3. So this, okay, what I'm going to do? I'm going to heat it with sodium. So again, this is what your Woods reaction. Okay, so what I'm going to get now here? So I'm going to get, okay, so CH2, so here, so CH2, CH2, then I'm going to get, so this is a CH3 here, CH3, so this is first carbon here, 2, 2, 3, 3, then this is 4, 4 and CH2, like this. Okay. So what is the name of the compound? It is cyclobutane. So option number A. Option number A. Okay. Statement with respect to SN1 and SN2 mechanism for alkyl halide is a strong nucleophile in a protic solvent increases the rate or favors SN2 reaction. B. Competing reaction for an SN2 reaction is a rearrangement. C. SN1 reaction can be catalyzed by some Lewis acids. D. A weak nucleophile and a protic solvent increases the rate or favors SN1 reaction. So, in an incorrect statement with respect to SN1 and SN2 mechanism. Now, when we see a strong nucleophile in an aprotic solvent increases the rate of or favors the reaction. Yes. So when you have SN1 reaction, for that polar protic solvents are used. Okay. And for SN2, polar aprotic solvents are used. Okay. Now polar means polar group. Okay. Polar compound. So with that, your protic means hydrogen attached molecule or compound is present. Polar aprotic means there is no presence of hydrogen. So such compounds are present here. Now SN1, it favors in the place of polar protic, and SN2, it favors in the polar aprotic. Remember this. So this is correct. Now competing reaction for SN2 reaction is rearrangement. Now when SN2 mechanism undergoes, what type of arrangement it forms? It forms a inversion product, right? The product form is inversion, and there is no rearrangement taking. So this is a wrong statement. Okay. In SN1, you have racemization. You called it racemization, or you called it as retention of configuration. You can see maximum. Okay. Retention of configuration. But when you see SN2 mechanism, you call it inversion. So there is no rearrangement. So this is a wrong. Okay. And SN1, it can be catalyzed by some Lewis acid. So this is also correct. A weak nucleophile and a protic solvent increases the rate of SN1. So this is also correct. So which is wrong statement? It is option number B. Okay. It does not undergoes rearrangement reaction. It undergoes inversion of product. Okay. Just a second. I'll see some more questions. Understood up to here?
Yes, ma'am.
Okay. I have few more questions. We have seen 15 questions, right? Okay, let us go further. Okay, so let us solve. Okay, so can you see now? Okay, so 18th question. Okay, so there is a compound Mg in the presence of dry ether is giving you E. This A further undergoes acid hydrolysis to give you B. So you have to find what is this product B. Okay, so what is the product? So when your this is a cyclobromo, this compound, right? Now this is reacting with a Mg. So it is undergoing what? So this is your Grignard reagent, right? So what it will form? What will be your product form? First A. So it will be in the presence of, so it will be MgBr. Okay, RMgX. So like RMgX it is forming. So organic compound is reacting with your Mg in the presence of dry ether. It gives you a Grignard reagent. So Grignard reagent is formed. Now this Grignard reagent further it is reacting with, or it is undergoing acid hydrolysis. So acid hydrolysis means what? Your OH group will attach here. So now what you are going to get? So the remaining compound will be same. So I'm going to get what here? So here your cyclo, so this is MgOH, okay, and your Br. So this will undergo acid hydrolysis, okay, to give you cyclohexane 1, 2, 3, 4, 5, 6 cyclohexane plus MgOH Br. So which is answer? Option number D. Option number D. So you are going to get a cyclohexane. So this is a type of addition reaction, that is Grignard reaction. Okay, Grignard reagent reacting with Grignard reagent. Okay. So the order of reactivity halogenation is. So what is the order of the halides for dehydrohalogenation? So when you see the halides, okay. Now when you see the reactivity series, first we have fluorine, chlorine, bromine and iodine. As you go down the group, what will happen to the size? Size will go on increasing, right? Fluorine will have small size and this will have large size. So as the atoms are large, okay, so the alkyl and the halogen bond will be stronger. Okay, so when you see the reactivity, so Ri, that is your alkyl iodides, are more what you say, they are more stable, then your bromides, then your chlorides, and then your fluorides. So option number D is the answer. So when you see the reactivity series, why? Because of the size. Because fluorine is having a small size. As you go down, what will happen to the size? The size will be more. So iodine will have a larger size. So the bond between the alkyl and the iodide will be stronger. Okay. So option number B is the answer. Which of the following statement is true in case of alkyl halides? They are polar in nature, they can form hydrogen bonds, they are highly soluble in water, they undergo addition reaction. So alkyl halides. Now already the answers are given, okay? But you should, so alkyl halides. Now alkyl halide is this. Now why it is polar in nature? So the answer is A. Why it is polar in nature? Okay, now if I take a example, alkyl group CH3 and I'll take a Cl group. What is a chloro group? What is a chloro group? Chloro group is a halogen, right? It is a halogen atom. Halogens are highly electronegative, right? They are highly electronegative. Why they are highly electronegative? Because they have the tendency to attract the electron towards itself, right? They have the tendency to attract the electron towards itself. So what it will do? Okay, it will pull the electron towards itself. So as a result, what will happen? Your CH3, okay, when this bond is broken, so CH3 will be left with no electrons, but the chlorine, okay, while leaving, it will take a pair of electron with it. So because of this, alkyl halides, they are said to be polar in nature. Okay, why? Because chlorine is highly electronegative atom, so it will tend to pull the electron towards itself. So as a result, your methyl group, okay, it will form a carbocation. What do you mean by carbocation? There is no electrons. Okay, it is electron deficient. Okay, it is not having extra electrons, or it is not having its own electron. It is electron deficient. But chlorine, it is having a pair of electron. Extra electrons are there. So it is having negative charge. Negative means additional electrons are present. Positive means it is electron deficient. Negative means electron rich. Okay, so because of this, alkyl halides are highly polar in nature. So rest all options are discarded. So option number A is the correct answer. Okay. Tertiary alkyl halide is practically inert to substitution by SN2 mechanism. Why? What is the reason? Now we said that, okay. Can anybody tell me? The answer is D. Can anybody tell me why tertiary alkyl halides are no, inert, practically inert to substitution of SN1? Now when we see SN1, tertiary are more stable, then secondary and then primary. When we see SN2, primary are more stable, then secondary and then tertiary. What they have said, SN2 mechanism, okay, why they do not undergo what you say, tertiary tertiary alkyl halides, why they are not undergoing SN2 mechanism. In SN2 mechanism, what is the step? The attack of the nucleophile takes place from behind the carbon, right? So can anybody tell me why the answer is D? Yes, can anybody tell me why the answer is D? I have not written any other structure. The same molecule, I have written the complete structure, right? CH3, I have written it in the complete form. Now this is your tertiary alkyl halide. Now I am going to do a SN2 mechanism on that. So in SN2 mechanism, the attack of the nucleophile is taking from behind. Okay. Now, do I have any space to enter and attack to carbon? No. Why? Because CH3 group are the bulky groups. Okay, CH3 group are the bulky groups. So there is a steric hindrance. Okay, there is a steric hindrance. So oxygen also molecular mass is 16 plus 1, 17. So this is also a bulky group, right? So the attack of this nucleophile from behind, it is very practically, it is not possible because of the steric hindrance. So we say tertiary carbocations in case of SN2 is practically inert. Okay, it is not possible. So because of that, we take what? We take methyl bromide. That is your primary carbon. Why? Attack is possible because hydrogen. Okay, very small atom. So attack is possible from behind. Okay, so when we compare SN1 and SN2, so in SN1 your tertiary are more stable and in SN2 primary are more stable. Understood why tertiary carbocations or tertiary alkyl halides, they do not show SN2 mechanism because of steric hindrance. Why the methyl groups are the bulkier groups? Okay, they are the bulky groups, and because of that, it is impossible for the hydroxide to attack from behind. Okay, fine. Okay, just a second. Huh? Okay, so the compound having longest CCl bond is the compound having longest CCl bond is A, this is a chlorobenzene, okay. So here, this compound is what? This is a you have one chloro, B option, okay. B option is one chloro, 4 nitrobenzene. Then this is a, it is like, this is a D option is a vinyl chloride, right? You know what are, so yes, study the terms, okay. All those terms, allyl halides, vinyl halides, okay. Then vinyl halides, then benzylic halides. Okay, so these are terms, please study, very important. Okay, now here they have asked which is the longest CCl bond. Okay, longest CCl bond. So these are the four options. Now we see a chlorobenzene. So in chlorobenzene, then your one chloro or four nitrobenzene, and in your vinyl chloride. So there is a double bond formation taking place, right? So there is a next to your chlorine atom, there is a double bond, right? Next to your chlorine atom, there is a double bond. Okay. So because of that, what happens? So the formation of double bond takes place. Okay, between the CCl bond, there is a formation of double bond taking place. Why? Due to resonance. So due to resonance. So because of resonance between your CCl bond, there is a double bond present, right? But when you see your option number this, okay, this option number C, when you see option number C here, what you can see, so this is 1 2 3 and 4, so this is 4 chloro, 4 hexene. So 4-chlorocyclohexene. So at your 1, 2, 3, 4, 5 and 6. So in your 4-chlorocyclohexene in this compound, what you can see, no resonance takes place. Why there is no resonance, students? Because there is no double bond present next to the halogen atom. Okay, so conjugated system. What is resonance? Resonance takes place in the conjugated system. Okay, because there should be presence of alternate double bond. So alternative double bond should be present. So then only the resonance is taking place. But in this compound, okay, you can see there is no alternate double bond. But here you can see, okay, so there is no double bond next to the Cl atom. The double bond is far away. So because of that, because of no resonance, CCl bond will be the your what it will be the strongest. Okay, it is having the longest bond. Okay, it will have the longest bond. So others, due to resonance, the bond will be less. Okay, but here it will be longest. Why? The double bond is not present. So option number C. So option number C is the answer. Can you tell me the IUPAC name for this compound? Just see the compound and tell me the IUPAC name. I'll give you the compound here. IUPAC also you need to study, very important. IUPAC. Tell the IUPAC for this compound. So this is a ethyl group. This is a nitro group. This is a fluoro group. Okay. So tell me, you how it should be named.
Or if the
So you have to follow the numbers, this alphabetical order. Okay. Yes. And what you have to do? 1, 2, 3, 4. It should get the least number, right? So if I start with this 1, 2, 3, 4, 5, and 6. Okay, now you can give alphabetical order. So first will be your
or
ethyl.
if that one of
Ethyl,
fluoro to nitrobenzene.
then 1 fluoro,
One fluoro
and then 2 nitro
nitrobenzene.
benzene. Yes, so option number A is the answer. Okay. So prolonged exposure to of chloroform in humans may cause damage to liver. Okay, why? It is due to the phosgene. Okay, due to exposure to phosgene. So when chloroform, so chloroform, what it contains? It contains the phosgene. Okay, so when your chloroform Cl3, when it reacts with oxygen, okay, when it reacts with the oxygen or the air, okay, in the presence of the UV light, it forms phosgene. Okay, and it will cause damage to the liver. So carbonyl chloride, this is also called as carbonyl chloride. Very important. Remember the formula for phosgene. Okay, carbon, or it is called as carbonyl chloride, that is COCl2. COCl2 is phosgene or carbonyl chloride. Is it clear?
Yes, ma'am.
All the questions are clear?
Yes, ma'am.
Okay. So please try to solve many more questions, okay, from this chapter. Any doubts in today's session?
Ma'am, question number 18.
18.
Yeah, ma'am.
Okay.
Yeah, I didn't get the explanation.
Okay. Now here, okay. So this is the organic compound. Okay. This is your organic compound RX, alkyl halide. Okay. Plus Mg. Okay, so what it is going to form? It is going to form a Grignard reagent, RMgX. What it is going to form? RMgX. Now this RMgX, further when it undergoes acid hydrolysis, okay, what I'm going to get? Organic compound. I'm going to form a organic compound, plus I'm going to get a your MgOH, and that your X. Okay, so here I'm going to get a organic compound, and here I'm going to get a the same way it is. So in the presence of dry ether, what I'm going to get? I'm going to get a R. Okay, so this compound, then you are going to have MgBr. Now this further on hydrolysis, I'm going to get the compound plus MgOH. So it is undergoing hydrolysis. Hydrolysis means what? Now directly we have written. But what are the steps involved here? Now this is Br plus Mg in the presence of triether. So first step is addition of RMgX. So you are going to get MgBr. So this is RMgX. Okay. Now further it is undergoing acid hydrolysis. Now this they have written directly D, but what is the step involved here? Okay, RMg. Okay, sorry, RMg, Mg, OH and Br. Okay, so this is your addition reaction. Further, when it undergoes acid hydrolysis, when it undergoes hydrolysis, so what will happen? This bond is cleaved. Okay, and then you are going to get Mg, OH and Br like this. So our option is D. Is it clear?
Yes, ma'am.
Okay. Any other doubts? Okay. So try to solve much questions. Okay. So I think many questions we have solved in today's session. Right. So SN1, SN2 mechanism, all the name reactions, very important they are. Then study the stereoisomerism part. What is optical activity? What is racemization? What is inversion? What is meso compounds? What are enantiomers? Right. So these all things you study. Then SN1, SN2, all the name reaction, Woods reaction, Woods-Fittig reaction, Fittig reaction. Okay. Finkelstein reaction, Darzin's reaction. So all the name reactions, Schwartz reaction. So all the name reactions are very important for board exam, as well as what they'll do the same. They will ask you in the question forms. Okay, in the in little twisted manner in MCQs form. So we have seen right 2-3 questions we have seen on Wood's reaction, how they have twisted and they have asked. Then IUPAC nomenclature is very important. Okay, based on IUPAC nomenclature also questions are asked. Okay, fine.
Yes.
Okay, fine then. So I'll end the session here. Okay, so we'll meet in the next class. Thank you.
Thank you, ma'am.